Alright, today's video is going to be on expanding logarithms using the property of logs, which here are the first 3 of the 5 that we've learned in class. So, definition of logarithms, just a reminder, it says that the log base b of a equals x is the same thing as saying b to the power of x equals a. The product property says that the log base b of x times y is equal to log base b of x plus the log base b of y. And the quotient property says that the log base b of x divided by y equals the log base b of x minus the log base b of y. And the other 2 properties that we have are the change of base property and the power property. The change of base property says that the log base b of a is equal to the log of a divided by the log of b. Now notice in this case I'm changing them to a base of 10. That's why I don't have the base written there, because with the base of 10 you don't need to write the 10. However, you could put any base in there. So you could do the log base 8 of a divided by the log base 8 of b. But since our calculator does a log base 10, it's easiest for us to change it to a log base of 10. Now the power property says that the log base b of a to the power of n is equal to n times the log base b of a. Now let's put these properties to use and expand some logarithms. So if we have the log of 100x, this is really saying the log base 10 of 100 times x. So since it's a multiplication inside of the logarithm, we can go ahead and use the product property, which tells us that we can split this logarithm into 2 separate logs, keeping the base the same, but separating the log of 100 and the log of x into 2 separate logs. And we combine these logs then with addition. So when it starts with a multiplication problem, we can expand it out and turn it into an addition problem, which makes it a little bit easier for us if we were trying to solve the problem, because in this case, since we have a log base 10, remember when there's not one here, it's a 10, we can actually look at this first logarithm right here, and the log base 10 of 100 is asking 10 to what power gives me 100, and either by knowing that 10 squared is 100, or by going to your calculator and typing in the log of 100, you could figure out that this part right here that I've underlined is really just the number 2, because 10 to the power of 2 will give us that 100. And so it ends up being 2 plus the log of x, which if we were trying to solve this equation, this would get us one step closer to our solution, since we now have the log of x all by itself, and we can work out what it equals. In this case, since we weren't given the log of 100x equal to some number, we don't have a way of solving because we don't know what it ends up equaling. But this is just a process of expanding it out so that we can get closer to solving it, if that's what we were doing. Another time we may find it useful to use the product property is even when there's not a clear multiplication problem inside of there, but we do have a base of 10 again, and now in our argument we have 300. And so I'm looking at this as the log base 10 of 300 and thinking there's no multiplication there, but I could rewrite it as the log of 100 times 3. And the reason this might help me out is because now that I have that log of 100, with the base of 10, just like in the previous example, if I separate it out into the log of 100 plus the log of 3, I can see again that this log of 100 is going to equal 2. So I have 2 plus the log of 3, which helps me get closer to my exact answer, and would just make it easier to simplify a problem if we were asked to simplify something. Now this is just something that I'm showing you can use it for. In my class on a quiz or test, if you have the log of 300, I would just expect you to type that into the calculator and get a decimal approximation, unless it's specifically said to simplify and leave an exact form. Now if we move on to the next property, which was the quotient property, here you can see that we're taking 3 and dividing it by 8 within the logarithm. So we've got the log base 10 of 3 divided by 8, or just the log of 3 divided by 8. Again, when it's a base of 10, you don't have to write it, and you don't even have to say it. So using the quotient property, we can separate this logarithm into 2 separate logs. So we would do the log of 3 minus the log of 8. Now in this case, we don't have any that are going to end up being a perfect number, because 10 to any power isn't going to give me 3 if that power is a whole number, and 10 to a whole number power is also not going to give me 8. So in this case, I wouldn't try to simplify it any further. I would just leave this as my final expanded answer, and that would be all we'd have to do in this example. In the second example here, I'm changing the base now, and I'm using a base of 4 instead of a base of 10. So I have the log base 4 of 16 divided by x. So when I rewrite this, I would have the log of 16 minus the log of x. And actually, I'm sorry, it'd be the log base 4 of 16 minus the log base 4 of x. Right? Now, since I'm using a base of 4 in this case, if I look at this first one here, it's really asking 4 to what power gives me 16, and we know that 4 squared gives me 16, so this would equal 2, so I could do 2 minus the log base 4 of x. Now here we have another example where we have the log of x squared, and this would be one where we would want to use the power property since we're taking the x to the second power. And with a logarithm, you simply take that power of 2 out in front and multiply it by the log of x. So I don't even have to worry about the exponent, I just move it out to the front, and that's done. That would be expanded. Unless you were asked to solve this equation, you wouldn't have to do anything further. Now in this case, I have the log base 3 of 81 to the power of x. Even though x is in that exponent, I can do the exact same thing with the power property, and I can move the x out to the front, and just multiply this by the log base 3 of 81. And I could type that into my calculator to figure out what the log base 3 of 81 is, or if you happen to know 3 to what power equals 81, you could just solve it in your head, because this is a perfect power. So 3 to the power of 4 actually equals 81, and so this would equal x times 4, or you could write that as 4x, which would be your final expanded and simplified answer. And so again, this is just helping us in getting closer to being able to solve logarithms. Now here's an example, like most of the problems you're probably going to see, where it's not just one step. It's not just the power property, or just the quotient property, or just the product property. In fact, we can use all of those properties within this one example. So what do we do first? You want to think about order of operations, which tells us to do things inside of parentheses and groupings first. And so if I look inside of these parentheses, I'm not seeing anything that I can reduce. The 125 times x divided by 27 doesn't simplify any further. So I'm going to leave that the way it is. The next thing that we look at is exponents. So I'm looking at this power of 3, and I know that since it's a power of 3, I can use the power property of logarithms, and I can get rid of it by moving it out into the front, and making this 3 times the log base 5 of 125 times x divided by 27. Now I look at what's inside of those parentheses again, and I try to think what can be the next step that I could do. And I see that I have 125 all divided by 27. And so since I have that really big division problem, I'm going to try to split that up first. So I'm going to put my 3 out in front, and then I'm going to have the log base 5 of 125 times x minus the log base 5 of 27. Now, if you notice, this 3 up here is being multiplied by everything that's in that log. So this 3 right here needs to be multiplied by all of this that we just expanded out. So you need to put parentheses, or if you don't like parentheses, since you already have parentheses around the logs, you could also use square brackets to show that you need to distribute that 3. Now, I still can expand this further because I have this 125 times x right inside of this logarithm. So I'm going to go ahead and expand that out. So I'm still going to have the 3 and the square bracket, but now I'm going to have the log base 5 of 125 plus the log base 5 of x minus the log base 5 of 27. And so what I did there is I expanded this first logarithm of the log base 5 of 125x out using the product property into 2 separate logarithms added together. And that could be your final answer. However, you could also simplify this log base 5 of 125 since there are no variables in it. It could just go straight into your calculator and you would get 5 to the power of 3 is 125, so this would equal 3. So you'd have 3 times 3 plus the log base 5 of x minus, and again, you could type in the log base 5 of 27 into your calculator as well, but it's going to give you a decimal, and so for the purposes of this, I am just going to leave it as the log base 5 of 27. And that would be the expanded form of this logarithm. And I think since I'm at 12.5 minutes that this is going to be the end of this video. Thanks for watching, and I'll make another one on condensing logarithms and also solving exponential equations using logarithms.